Hello, welcome to my channel. So in today's video will be the problem number 5 of the curvilinear motion. Okay, so um, in this problem will involve a lot in geometry, mathematics, and how to interpret the constraint curvilinear motion. Okay, so firstly, let's dive onto the problem statement. Okay, this problem say that the hydraulic actuator moves pin A along the slot arm at constant speed v. So that this is the hydraulic actuator. Okay, so it moves along this axis and push the slotted arm of the green slotted arm forward into this direction. Okay, so it create the rotation of motion in that period. Okay, so this is the axis rotation O. Okay, once the pin A is pushed this side, that means this slotted arm will be rotated. So yes, like mentioned, this linear motion causes the slot arm to rotate about the fixed point O here. So at the instant when the angle theta is 30 degree, this angle 30, determine the following kinematic quantity in polar coordinates. Okay, so my correction, this 30 degree is not equivalent to theta. Okay, so this is the is a constant value that happen to be this hydraulic axis and the horizontal line at 30 degrees together, but theta will be depend on each state that there was in. So but the question just asked that the instant to find this quantity at the instant where theta equal to 30 degrees. Okay, so firstly, we try to determine what we don't know. So in this question, what we don't know is the radius r here. What would be the radius if the theta equal to 30 degree or theta equal to any degree? Okay, so firstly we bring the triangle here. I draw. I call this A and O here. Then we then assign the angle, the unknown angle here as alpha. Okay, so then we try to see that, okay, this angle alpha is equivalent to this angle alpha, right? So and also equivalent to this alpha as well. So from the triangle, we know that the angle inside triangle we combine it and equal to 180. Okay, if we combine alpha, theta 30 degrees and this 90 degrees equal to 180, then we get the relationship of alpha and theta shown here. So alpha equal to 60 degrees minus theta. And then if we write in the radius term, we get pi over 3 minus pi theta. Now, if the sine law is applied here, we will know that the radius r here divided by sine 30 here will equal to this length of 0.5 meter divided by sine alpha, right? So if we rearrange it, we will get that r equal to 0.25 divided by sine alpha times sine 30 degrees. So that means r dependent on alpha, and then alpha dependent on theta. Okay, so it's safe to say that now r is dependent on theta. So we'll then write r as function of theta shown here. Substitute alpha in this bracket. Then we get the radius in any theta given. So then we move on to the in term of theta dot and theta double dot. Okay, so we know that this v will push the pin A toward this direction, and that is the same magnitude v here that was put. Then again I place the reference axis shown here R pointing outward, the center of rotation, theta pointing perpendicular to the r-axis toward the same direction with theta. So theta will try to move in this direction, so I put the positive theta as here. Okay, but of course, in your case, you can change the axis or the position of the theta and r uh, as you like. Make sure it consistency and r is in this along this axis. Okay. Okay, so next we will try to distribute the velocity v into vr and v theta here. So v theta, okay, this v theta equal to v times psi alpha here. Then v theta from the velocity vector will generally equal to r theta dot. This is from general. Okay, so we then equivalent these two. We get that the 1.5 sine pi over 3 minus theta equal to r theta dot. Then we rearrange a little and substitute r from here. Then we get ourselves a simplified version of of theta dot that depend on theta, like this. Okay, and surely if we differentiate this with respect to time, we will get our theta double dot. Okay, so in this portion, I already tell where it came from. Basically from differentiate of psi powered by 2, then we push 2 in front, and then indicate psi, we got cos, and then indicate what inside here, we get -1, and then theta dot, the theta over dt. To simplify that, we then got this as a general equation, as a relation of theta double dot depend on theta. Okay, so I think it's long enough for the first part of the problem. We will continue this problem on the next part of the video. Thank you for watching. Please stay tuned for the next video so that we can completely solve this problem together. Okay, thank you so much for watching. See you on the next video.